Hello friends, welcome to Shiksharthi. In this video, we'll be discussing question number 5 to 8 of exercise 8.1 on trigonometry. So let's start. So talking about question number 5 now. So question number 5 says, given sec theta is equal to 13 by 12, calculate all other trigonometric ratios. So as discussed earlier in other questions also, draw the diagram first. So what is this piece of information? I can always put it here. But before I do that, what I have done here is I have made a table. Now I know that I am supposed to calculate all the trigonometric ratios, and there are 6 trigonometric ratios only. So starting from sine, cos, followed by tan. Sine theta perpendicular upon hypotenuse, cos theta hypotenuse upon perpendicular, cosec theta. Cos theta base upon hypotenuse, sec theta hypotenuse upon base, tan theta perpendicular upon base, cot theta base upon hypotenuse. Once you have done this, and then we can always plot this. We know sec theta is equal to hypotenuse upon base. So hypotenuse, let's say here is 13x, base is 12x. Now you can use the Pythagoras theorem here, but before you go ahead, you just need to specify x is non-zero positive real number. That is the only thing that you need to specify here, right? Once you have done this, so you can just use the formula, which is Pythagoras theorem. So you need to find out perpendicular, right? So p square, now using h square minus b square, can be written as h minus b into h plus b. So from here you will say this is nothing but 25x square. So you will get two values of p from here. One is plus 5x or minus 5x. Now you will be using both, but at a time use only one. So either I do it by PBH, or it is advisable that once you know what is a PBH rule, now PBH rule you need to know where plus, minus and so on. Now we know that AS, all students take care, which is all sine, tan, cos. Once you know this with respect to 4 quadrants, you can simply pick up this piece of information. So which says, now this is just like saying sec, you already know cos theta now, which is 12 by 13, and sec theta is given to you as 13 by 12. So which means we are basically talking about the first quadrant, and we know that in the first quadrant all the trigonometric ratios are positive, and in the fourth quadrant it is only cos and sec which are positive. The remaining would be negative, right? So here I'll put these values only. This is the first thing you would do, because these are the easiest set of values that you can put here, and it's better now you use the sign here. So let's say plus plus. Here all the remaining 4 values would be negative. Here all the remaining 4 values would be positive, because first quadrant all of them are positive. Now perpendicular upon hypotenuse. Perpendicular, so we can just put this value as 5x for the perpendicular here, and minus 5x we will use accordingly based on the quadrant. Rather than writing here as plus 5x and minus 5x, I have just written 5x, and then based on the quadrants we change the polarity. Okay. So perpendicular upon hypotenuse is how much? 5 by 13. Here it becomes minus 5 by 13. Reciprocal of this is nothing but 13 by 5. And here it becomes minus 13 by 5. Now tan theta is perpendicular upon base. So we'll write it as 5 by 12. And here plus, here it becomes 12 by 5. And here this would be negative. So finally sec theta is positive in which quadrants? The first quadrant and the fourth quadrant. So now since sec theta is positive in the first and the fourth quadrant, and this is expressed in terms of a ratio, which is why we are considering both the quadrants. Had they given specific values, I repeat, if they would have given sec theta, let's say they would have given the hypotenuse is 13 centimeter and the base is 12 centimeter, in that case you would have taken the values only from the first quadrant, because then they would have given you the value. But the moment the value is expressed in terms of a ratio, in that case you have to talk about all the quadrants. right? Let's talk about the next question, question number 6. So question number 6 says, if there are two angles, angle A and angle B, if they are acute angles such that cos A is equal to cos B, then you need to show that both the angles are equal. Now, if you recall, we have been talking about this right from question number 1, that if the question does not specify what type of an angle is, then you are supposed to consider cases, which is why we have been considering positive as well as negative values. But here in the question, they have already mentioned that angle A and angle B are acute angles. Okay, let's draw the diagram. Now, since there angle A and angle B is what we are talking about, so we'll take this as C. So it says that cos A is equal to cos B. So now we know that this is perpendicular, this is base, and this is hypotenuse. Okay, it is already given. So it is given as cos A is equal to cos B. And why have we drawn this orientation? Because the question says that A is an acute angle. If you recollect, we'll take it only in the first quadrant. We are talking only about the first quadrant. So what is the interpretation of this? We are talking about the first quadrant. We will not talk about any other quadrant. Okay, having said this, now what are we supposed to do? How much is cos A? Cos A is base upon hypotenuse, which is equal to cos B. Now this is B. So cos B is equal to base upon hypotenuse. So from here I can write that B by H minus P by H is equal to 0. From here I can say B minus P upon H is equal to 0. And in a triangle we know that hypotenuse is a non-zero and positive length. Hypotenuse is a non-zero and a positive length. So from here we'll be able to say, therefore base is equal to perpendicular. So we are saying what? This side is equal to this side. So now this, instead of P, I can write it as B. Okay, so in a triangle, if there are two sides which are equal, their corresponding angles would also be equal. So this angle becomes equal to this angle. So proved. So therefore B is equal to P. Hence, you can say, hence angle A is equal to angle B. Right? I hope so. This was a good question, and this I think has been understood by you. So next we will talk about question number 7. So question number 7 says, if cot theta is equal to 7 by 8, then you need to evaluate these two. So the first is 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. And the second one that you need to evaluate here is cot square theta. Okay. Now talking about this question, there are many ways of attempting this question, but I would start off with the basic way first, and maybe if other ways are also to be discussed, we will talk about them simultaneously. Okay, so can we make a triangle here? Yes, we can make a triangle. Now nowhere have they mentioned that theta is an acute angle triangle. So there are two different values that you can get from here, but we know that tan or cot are positive in the first and the third quadrant. So we are basically going to talk about the first and the third quadrant. Please keep this thing in mind. Now the moment I write Roman numbers, that means I am talking about quadrants. Please keep this for further discussions. Okay. So let's say this is A, this is B, this is C, this is base, perpendicular, hypotenuse. So cot theta is equal to base upon perpendicular. So let's say this is 7x, this is 8x. So hypotenuse square will be nothing but p square plus b square, which is just like saying 64x square plus 49x square, which comes out to be how much? 113x square. So h will be plus x root 113. or minus x root 113. Right? But before we do this, it is better that we should have specified that x is a non-zero positive real number. Yeah, this is equally important. Okay, once you have done this, now let us see what does it boil down to basically. So as I said, use the concept of PBH. So this can be written as this is 1 plus perpendicular upon hypotenuse. Keeping in mind that this is nothing but cot theta is nothing but base upon perpendicular divided by how much? Now, so this 1 minus p this is b upon h and this is 1 minus b by h. So this is just like saying h plus p into h minus b divided by h plus b into h minus b. Further to this, we could have written this is nothing but h square minus p square and this is nothing but h square minus b square. Now h square minus p square can be written as b square and h square minus b square can be written as p square, which is just like saying this is nothing but cot square theta. Right? So you would see that this question number 1, subpart 1 and subpart 2 are nothing but you can use this as a standalone property and you can say 1 plus sin theta into 1 minus sin theta upon 1 plus cos theta into 1 minus cos theta can be written as cot square theta. Right? And how much is the value of cot square theta? This is nothing but 49 upon 64. So you will see that this is basically not required. If you are using this, you'll be wasting your time. And the same value you could have substituted here. Now, using another way of doing the same question, now using trigonometric identities. So here, so let's say this is another way of doing the same question. So I could have used a plus b into a minus b, which is just like saying this is nothing but 1 minus sine square theta divided by 1 minus cos square theta. Now using trigonometric identity, which is sine square c plus cos square c is equal to 1. Using this identity, we can say 1 minus sine square theta is equal to cos square theta and 1 minus cos square theta is equal to sine square theta. And cos theta upon sine theta is basically what? So that we can check it out from here, or we can say we had done something like tan theta in our videos. We had done tan theta is equal to sine theta upon cos theta is also an identity. So similarly, I can say cos theta upon sine theta is equal to cot theta, which is just like saying this is cot theta whole square, which is cot square theta. So let's say had you not known this identity, which you can't afford to do this, you are supposed to know the identity. Even if you would not have known this, still you could have established. So this is a way of establishing the identity only. Right? Let's move on to the last question, which is question number 8. So question number 8 says, if 3 cot A is equal to 4, then you need to check whether this expression is equal to this or not, this expression, let's say cos square A minus sin square A. Again, there are many ways of attempting this, but first I would use simply the concept of PBH. That means if I know that, I may not use this piece of information and I know that cot A is basically what? A base upon a perpendicular. Right? And then I need to do what? Let me first solve for the LHS, which is left hand side, and let me keep this as RHS, right hand side value. So now when I solve for LHS, left hand side, I'll say this is 1 minus p by b whole square divided by 1 plus p by b whole square, which is just like saying b square minus p square upon b square plus p square, because this b square and b square would eventually get cancelled out. Here using a square minus b square formula, which is just like saying this is b minus p into b plus p upon h square. So either I use like this, but the moment I write it like this, I see that this expression is not helping me at all. So what I'll do is, instead of writing this, I would not convert it into this, and I would simply write it as, this is b square minus p square upon h square, using Pythagoras theorem, which can further be written as, this is b square by h square minus p square by h square, which can be written as, now how much is b by h? Cos. So cos square a, and p by h is sine. So even if this value would not have been given to you, still you can calculate and you can say that yes, this expression is equal to this expression. Now since they have given you this value, you can always substitute this value and you can get the answer. Though suggestion here is, you can simply use PB and you can say that this P and B are nothing but the same values that you are using. So you could have said, so we could have made a triangle here first before we could have begun, and we could have said that this is P, B, H. These are the set of values that we are considering for this entire question. Given that this is angle A, this is, let's say, angle D, and this, let's say, is angle C, such that A, this angle A was given to us, which is cot A is equal to B by P, and the same set of values is what we have used here. So rather than substituting it as 4 by 3, what are we saying? We are saying B is equal to, let's say, 4x, and P is equal to 3x is what we are saying. But without taking the values, we could have just generalized the solution, and then we could have said that left hand side value is equal to this, which is equal to the right hand side value, hence proved. Right? I hope all these questions that we have discussed in this video, question number 5 to question number 8, have been fairly understood by you. Now any set of questions that we would be discussing, if you want to really understand them carefully, please watch them again and again so that you are able to understand what is the way to go ahead with the questions. Right? If you feel that something very, very informative has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some specific videos on some specific topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.